In this video, we're going to look at the distribution of sample percentages for n equals 100, and I've made a population and a trait up to contextualize our understanding of this chart. So we're going to say that the trait we're interested in is that someone likes action movies, and we're going to say our population we're interested in is all U.S. adults 18 and over. Okay, so we would take a sample of size 100, a representative simple random sample perhaps of 100 people out of this population, and we'd ask them, do you like action movies? If they said yes, that would be a 1. If they said no, that would be a 0. Okay, so the histogram below shows the distribution of sample percentages for a sample size of n equals 100 and a population percentage of p equals 51% for sample percentages ranging from 46% to 56%. Okay, so let's look at this diagram. Again, this is our sample percentage, is our horizontal axis, and we have on the vertical axis percent of samples. Okay, which almost sounds like the same thing, but again, they mean something different. And let's start to interpret some of these values just to get a feel for it. Okay, so notice this is just the center of the histogram, and we have 51%. We're assuming that we know that this is the true population. Again, this is not actual data of these traits and populations. I just made these up to contextualize it. Okay, so suppose we know that 51% of U.S. adults 18 and over like action movies. Okay, and we take a sample of size 100, and these are some of the sample percentages we can get. And since we have a nice sample size of 100 and percents are based on 100, these basically mean that you took a sample of size 100 and 46 out of 100 people said, yes, I like action movies. Similarly, this would be 47, 48, 49, 50 out of 100. Our true sample percentage is 51 out of 100. Okay, 52, 53, 54, and let's just label this one at the end. Okay, so remember what these percentages are representing. So this is the ratio of people who have the trait that you're looking for in the population. Now, what do the percent of samples mean? These are the percentages of all possible samples that would give you these sample percentages. So notice this actually runs from 0 to 100%. We're just focusing on the ones close to the sample percentage on this problem, and also because that would be a really, really big graph. Okay, so now let's read the questions. What percent of samples of size 100 equal the true population percentage of 51%? Okay, so notice which one are they asking us to find. Okay, so they're giving you one value, asking for another. We're trying to find the percent of samples. Notice we're looking for this value that have the attribute of equaling the true population percentage. Okay, so we go to our sample percentages. The true one is 51%. And on top, we have it labeled. Again, this axis is hard to read, so we label them on top sometimes just for clarification, 8%. So our answer to this question would be 8%. Okay, so think about what that means. If you sampled 100 people, okay, 8% of the time you would get the exact value, okay, the true population percentage. Okay, lots of times you would get close. Okay, you could get something far off, but it is possible, and actually it's the most likely out of all the other options that you'll get the true population. Let's look at the next question. What percent of samples, okay, so that means we're going to look at the vertical axis again, of size 100 are within 3% of the true population percentage. Okay, so let's find this on the horizontal axis. Okay, well, here's the true population percentage. Within 3% would be 3% in either direction. So we can add 3 to 51. Okay. So here we'd be within 3% of 51, And we can also look in the other direction. Okay. So we want to see the percentage of all samples that fall in this range. So we're going to need to add all of these values together. Okay, so the sum of these percentages would be the percent of all possible samples of size 100 that would be within 3 percentage points of the true value. So let's write these numbers out. 6.7, I'm going to leave out the percent sign since there's a lot of them, but at the end we'll label it a percent. 7.3, 7.8, 8, 7.8, 7.4, and 6.7. Okay, now we're going to add this on the calculator. 6.7, 7.3, 7.8, 8, 7.8, 7.4, and 6.7. And again, I always stop at the end to make sure that I got the numbers right. Okay, yes, punching in numbers isn't hard, but it's so easy that it's easy to make a mistake. 6, 7, 7, 3, 7, 8, 8, 7, 8, 7, 4, 6, 7. Looks good. And that is 51.7. Now we're going to make sure to add our percent symbol. Okay. So to think about that meaning, okay, if you were to take a sample of 100 people, a simple random sample of U.S. adults 18 or over, 51.7% of those samples, okay, would be within 3% of the true population percentage of 51%, in the range from 48 to 54.